It's great to be here in Hawaii for LocoMocoSec. I want to thank Jim and Neil for inviting me to talk. My name's Alex Smolen, and I work as an engineering manager for the security team at Clever. Let's get this. All right, cool. Today I'm going to talk about designing usable identity and access management systems. I'm going to use 3 real-world AWS IAM projects I built as examples. These projects cover key management for IAM users, least privilege for IAM roles, and the design of a CloudTrail auditing stack. Each project is accompanied by a blog post and source code, and I'll provide links to these at the end of the presentation. But first, I wanted to talk about the inspiration behind this talk. Okay. I know what you're thinking. How come that window isn't broken anymore? Terminator 2 isn't a perfect movie, but it's a pretty good one. How many people haven't seen Terminator 2? Okay, you can leave now. It's fine. No, I'm just kidding. If you haven't seen it, Los Angeles 2029 is an apocalyptic wasteland. A sentient robot uprising known as Skynet has decimated humanity. The few remaining survivors plan a last-ditch effort to save themselves from a time-traveling liquid metal assassin programmed to delete their existence by sending their own cyborg back to 1995. The human heroes-to-be and their robot protector face not only a fearsome villain but their own judgment against the backdrop of dilemmas of causality, free will, and morality. In case you can't tell, I'm a fan of the Terminator 2 film. I hadn't seen it in a while, but I was flipping channels, and it was on. And you know what? Rewatching it, I noticed some symbolism. I jotted down a few notes. It turned into a little bit of research. There's a bunch of critical analysis of T2 online, and people have noticed some strange things. There's biblical themes. You start the movie, you see children playing on a playground, and a nuclear bomb flash, and then the 4 horsemen of the apocalypse. It's pretty clear, right? So is it an allegorical Bible story, or is it the classic question of free will versus destiny? It seems clear that that's at least one theme of the film, but like any good time travel movie, there's conspiracy theories around it. Did you catch that? Yeah, I'm not the only one who thought this was weird. Another interpretation is that we are following Arnold's character, the menacing T-100, through a journey. Not that kind of journey, not that kind of journey, but the hero's journey. And yes, a film nerd online has actually mapped the whole thing out. But as I was watching Terminator 2 and taking notes, I didn't see these themes. Instead, I saw the film as an allegory about identity and access management. There's a battle between machines and humans. Our code is turned against us. And the only way for us to defend our future safety is to build more code and to teach it to protect us. Now, I had decided to use Terminator 2 as a theme in this talk, but I realized there's not much going on in the way of T2 GIFs online. I wanted to create a critical analysis of the film with some high-quality shots of robot versus robot action. But instead, you're pretty much limited to low-quality, overplayed GIFs. So I wanted to craft some HD GIFs. I needed to go to the source and get the gigabytes of digital video for carving up. So I went to the digital video stores online to buy the Terminator 2 digital video, but I realized I had a problem. You guessed it, copyright. So I decided to ship a plastic disc across the country, then ship a plastic disc laser reader also across the country, just to grab bits from the plastic disc instead of simply downloading the file. Now, why would I have to do that? Why couldn't I just purchase the file, load it into iMovie? Well, any digital version of T2 that you buy online has DRM, so you can't import it into iMovie. It turns out there's this legal concept called fair use. Fair use means I can take portions of copyrighted materials for certain purposes, presumably including this talk. So legally, I felt pretty good about purchasing the movie file and mining it for GIFs, but iMovie did not. You see, DRM is code and fair use is law. DRM and fair use are a battle between computers and humans. And I'm proud to say in this battle, I won. If you look at this frame rate, it's amazing. The bigger battle I'd like to talk about today is how to design usable IAM systems. Identity and access management systems answer two questions. Who are you, and what are you allowed to do? These seem like simple questions, but we have to answer them by writing code. And when we get the answer wrong, we end up with two outcomes that we don't want. If we're too permissive, we let bad actors abuse the good users of the system. And if we're too restrictive, we prevent our good users from getting values from the system we're trying to protect. As technologists, we may understand what we want technology to do, but we don't always seek to understand what the users of our technology will do with it. People on the other side of the screen don't realize how their use of technology will affect them. Writing code is hard because it's only a snapshot of our understanding of how the world works. Especially as code becomes more complicated, it can have unintended consequences. While some people build and use these technical systems without understanding their underlying power to harm us, those of us in security are meant to bridge the gap. Working in computer security is a great way to learn not only how dangerous technology can be, but how difficult it is to make it safe. As a security professional, you must find yourself asking every day, will technology destroy us? I try to be optimistic about our challenges, but it can be difficult when you've seen the dangers of designing IAM systems. Consider one of the oldest and most common mechanisms of IAM, the password. Our first presenter, LocoMocoSec, Troy Hunt, talked about the compatible time-sharing system, or CTSS. It was the first time-sharing computer, and it had user accounts. So it used the first computer passwords in 1961 to make sure that people could only get their fair share of time. Alan Scher, a graduate student, wanted more than his fair share on the CTSS. First, he found a way to escalate privileges using performance management code he had written so that he could zero out his time. The next year, when they removed that code, he found a different exploit that allowed him to request the plaintext password files to be printed out. He then snuck into the lab and stole them. You may think that we would have learned early on about the difficulties of designing identity, but we still make similar mistakes today, and our systems have grown both more complicated and more critical. From 2011 to 2015, I worked on security at Twitter. Our team owned the IAM stack, including features like password recovery, OAuth, 2FA, and suspicious login detection. Before I joined, the company's reliance on passwords for authentication had already had tremendous consequences. Another LocoMocoSec speaker used this photo, Jing Kim. It's of me and some coworkers talking about Twitter security in 2013. Here, I was talking about how Twitter received an FTC mandate for the compromise of Barack Obama's Twitter account through an externally reachable administrative interface with, you guessed it, a guessable password. The AP Twitter account's password was stolen, and a single unauthorized tweet led the Dow Jones Industrial Average, dropping briefly 150 points or $139 billion. There are many examples of the negative impact of password systems that are too permissive. But what about the opposite problem, where password systems fail users by being too restrictive? I've worked at Clever for the last 2 years. It's an education technology startup that helps students use technology in the classroom. It does this by federating school identity systems with educational applications. Millions of students and teachers in over half of the US K-12 classrooms use the Clever portal to single sign into their apps, minimizing the use of passwords. One problem we noticed is that when you're 5 to 7 years old and learning to type, it can take a lot of class time to enter even a single simple password. That's why we built Clever Badges. It's a feature that lets young kids use a QR code in their webcam to sign in instead of a password. It's much easier to hold up a picture that contains 96 bits of entropy. As a security-focused engineer, I was initially skeptical of something so different. Our team spent time talking with teachers, observing students, and understanding how districts manage student credentials. We threat modeled and we code reviewed what we built. But the way I explained why badges are a good thing for security is that they replace passwords with popsicle sticks. Most people aren't incentivized to solve abstract security problems. They just get by with what they have. And for young kids and teachers, what we saw in practice was really simple passwords and really questionable credential distribution methods. I don't think these popsicle sticks are encrypted. Designing resilient, flexible, and user-friendly IAM systems that mediate the most sensitive aspects of our social interactions is difficult. Each IAM system operates in a different context, and there is no one-size-fits-all way to design IAM systems. But to create systems that work hand in hand with people's interests, we need to have an open mind, and we need to keep our eyes open for inspiration. Terminator 2 didn't just inspire me, it also gave me the design principles for building usable IAM systems that I hope to share with you today. As I was watching T2, I'd been building and blogging, or was in the process of building and blogging, about 3 different projects. They were based on making sense of the identity and access management capabilities of AWS. Clever runs in AWS, and we rely on AWS IAM as a core part of our security infrastructure. And just like it's okay if you haven't seen Terminator 2, it's also okay if you've never used AWS before. Both were blockbusters of their day, so I'm surprised, but it's okay. I hope that I can use them as specific examples of broader themes about computer security. I want to talk about 3 projects I built as examples of how to design IAM for humans and computers, and how each was inspired by Terminator 2. It all starts with 3 tough problems we faced when designing our IAM system at Clever. The first problem is how do people authenticate to AWS. AWS has a variety of ways to interact with it via the command line in the web console, using access keys, passwords, and MFA devices, and it's difficult to know how to create a consistent authentication experience for a team. The second problem is how we can define least privilege for our code. The predefined AWS managed policies for defining privileges on AWS resources are pretty much all or nothing. And creating fine-grained IAM policies for each one of the hundreds of services in our microservice architecture was painful to get right. Finally, we knew we were going to get things wrong, so we wanted to audit the AWS API system usage using CloudTrail to make sure that we fixed what we didn't get right initially. To authenticate people in AWS, you need to help them manage private keys. This means keeping them private from everyone except your authentication interface. When we built two-factor authentication at Twitter, we included 2 mechanisms, SMS and a public key architecture where users stored their private keys on their phones. The second one doesn't exist anymore. And the reason is this. Perhaps the most optimistic folks in cryptocurrency assume that everyone can effectively manage a private key, but while we're learning to collectively engage in more sophisticated authentication ceremonies over time, we as humans are fallible and incapable of avoiding accidents at scale. So to teach machines how to trust humans, we need to design flexible key systems. And Terminator 2 has some insights for us. Here, we see an early example of multiple factor authentication. It's important to have multiple factors because passwords can be brute forced. Or people may not always practice the best key management. And who can forget about the danger of malicious code stealing keys? There's the failure case where people lose access to their keys. And what about the concept of least privilege? I'm pretty sure the keyhole for her jail cell should be on the other side of the door. And of course, we need to understand that if our systems don't let in someone who's supposed to be allowed access, it may cause some blowback. What we need is a system that gives people permission to do their work, but uses well-designed authentication factors or keys to help keep them safe. It should align the access control with the usage of these keys so that more dangerous tasks have increased friction. I wrote a blog post about a pattern I call IAM pseudo. And when I use the term pseudo, I'm referring to the pattern of tying the temporary elevation of privileges with additional authentication barriers. It's something that pops up fairly regularly today, like in the Google Administrative Console and in the GitHub danger zone settings. When you first create an AWS account, you create a root user that can do anything. AWS strongly recommends not using the root user, but instead creating IAM users and the credentials and access policies for them. But AWS IAM authentication and access control is complicated. The team of engineers I worked with was familiar with using managed passwords in a password manager, but it was tougher to guide them about how to store and use AWS access keys securely. Access keys are a credential pair consisting of an ID and a secret used for accessing AWS over an API. AWS suggests putting these keys in environment variables and config files. I was worried about the threat of malicious software exfiltrating these keys, and so I investigated tools that store them in the operating system keychain. This means you need to enter a password or approve a dialog when a new process attempts to access them. AWS Vault is an open source tool to store the AWS credentials in the OS keychain. In this example, we're using the home AWS Vault profile, which is associated with an IAM user and the protected access keys. The exec command creates a new subshell with temporary access keys, so they're harder and less valuable to steal. The STS API call I'm making here, getCallerIdentity, reflects the calling IAM user. In addition to access keys, you can add a multi-factor device to your AWS IAM user. You can choose to gate all access behind MFA, but an alternative is to gate dangerous actions behind a role that requires MFA access. You can think of and name this role pseudo. IAM roles are like IAM users without static credentials, like access keys and passwords. They can be assumed by an authenticated IAM user according to the rules, according to the roles assume role policy. When you assume a role, you get temporary access keys, which you can use to access the AWS APIs as that role. In our example, you could give the IAM user the read-only access manage policy and create a pseudo role that has the administrator access manage policy. This is just an example of how permissions might be divvied up in a real-world scenario. You'd want more tailored policies for pre- and post-pseudo that don't include broad cross-service, cross-resource access. You can then configure the assume role policy for the pseudo role so that it can only be assumed via MFA. This means that to check up on things, you don't have to dig your phone out of your pocket, but once you decide what you want to change, you can assume the pseudo role, authenticate, and complete your task. You can wrap this up with a set of bash commands that make logging in and out of AWS really fast. So as an example, here we're logging in with read privileges so that we can use the command line API. And again, this STS call tells us who we are. Here, we're logging in as the pseudo role. So in addition to unlocking the access key in the operating system keychain, we need to enter an MFA code. You can also use this to access the web console. So what this does is it makes a consistent MFA barrier across web console and command line access so that people are going to find it easier to use their access keys correctly. We're used to having security and usability be zero-sum, but the pseudo design pattern doesn't only increase security by requiring additional authentication. It increases usability by helping users feel safer. They're less likely to make a critical mistake when they haven't elevated privileges, and they won't be able to take harmful actions accidentally. When we write least privilege access policies, we embed expectations about the real world. Secure software is resilient, yet software designed to enforce security is often rigid and fragile. When we attempt to enforce behavior in a system with security mechanisms that don't align with users' risk perceptions, that security mechanism will be rejected, reducing overall system security. SecDevOps, or whatever you want to call it, is embedding security inside the development process as deeply as DevOps is done with operations. I think at its core, it's about replacing policy controls with technical ones. You replace manual code review with automated code scanning tools. Rather than relying on periodic assessments, you have dynamic testing tools that look for misconfigurations. You embed the values of the security team into code that expresses those values onto other people. We should think about how our code can embed the values of security without causing user pain. We should keep users safe, but also keep them productive. Designing sandboxes that limit the impact of bad code isn't like designing access control for people. We don't know exactly what people will do on a computer, and if your access control is too strict, you get in people's way. With code, it's the opposite. We know precisely what code is going to do, or at least code we write. Where possible, we should describe the limits of our code completely. To define least privilege for code, we need to be able to catalog exactly what our machine interacts with. Our code has a limited understanding of the environment. The defensive mechanisms in our code may be vulnerable to threats that we didn't understand when we wrote it. We believe that we have control over what our code will do, but we're surprised when our code's behavior doesn't match our expectations. When we attempt to describe the world of resources in AWS to our code through IAM policy, there's a steep learning curve that can make getting started tough. That's the reason for the Terafan project, which reduces the complexity of assigning least privilege to IAM roles used by code. IAM roles aren't only assumed by IAM users, like I talked about in the pseudo pattern. They can be assumed by AWS services, like EC2 instances and ECS container tasks. If you want to give your code access to AWS resources, you can use IAM roles and define JSON IAM policies that describe what they can access. Terraform is a tool for creating AWS resources declaratively. You write configuration, either in HCL here or as JSON, and Terraform creates an execution plan describing what it will do to reach the desired state, and then executes it to build the described infrastructure. With Terafan, instead of handcrafting IAM policies in the console or using the visual editor or writing lengthy and error-prone Terraform IAM policy configuration, You can use a terse YAML file to generate Terraform configuration files, which you can then plan and apply. This gives you all the benefit of infrastructure as code with a fraction of the code writing. Terraform uses a familiar subject action resource format to describe exactly what a machine can and can't access. The generated JSON uses modules to encapsulate frequently used permission stanzas and maintains consistency in policies across an organization. The resulting IAM role has narrowly carved permissions for accessing AWS resources, so it can be safely granted and reduce the risk of compromise of an EC2 instance or ECS service. When we think about controlling machine access, we should try to encapsulate machine-based, fine-grained policies into broader profiles that map well to human concepts. This makes it easier for us to read and write policies. When we build access control systems, we sometimes feel like the proverbial referee that's only noticed when they get something wrong. Like any system, we need to own the operational aspects of our IAM system so we can make sure it's working as intended. How do we know if the judgment we made about who was allowed to do what was correct? We can see how our IAM systems are being used, and by exploring that data from the past, we can reshape our code to better serve and protect our users. Imagine if you were the designer of seatbelts and you learned they weren't even used in the future. As engineers, we should consider the outcomes we want from our code. We may design a system that invades other people's privacy. We may think our machines are learning and we have artificial intelligence, but can we trust a world ruled by technology? To know if we're on the right path when we're building IAM systems, we need to understand our data and use it to make changes. This idea inspired the design of our CloudTrail auditing stack. CloudTrail is AWS's service for auditing API call logs. When you define IAM policy, you say what API calls should be allowed to happen, but you can be wrong in two ways. You can be too permissive or too restrictive. By using CloudTrail, you can find and fix both problems. CloudTrail logs are by default delivered to S3. It's up for you to figure out how you want to audit them. We built our CloudTrail auditing stack using Athena. Athena is an interactive query service that makes it easy to analyze data in S3 using standard SQL. Rather than relying on indexing CloudTrail logs in a search stack, like Elasticsearch or CloudWatch logs, where you're limited to non-relational search engine queries, we can use Athena as an interactive SQL query engine database to explore data. Are people accessing things that we didn't expect them to? Are machines not able to access things that we expect them to be able to access? We can see what a role has been up to for a particular month or the list of all unauthorized actions for a day. We can extend these foundational services to give us a monitoring stack that gives us insight into our code. In my blog post, I talk about how you can use Lambda and DynamoDB to create partitions in Athena, saving time and money by running queries efficiently. Because this data sits in S3, you can extend it with even further processing. For example, you could generate a diff report so we can zoom in on what changed, what actions happened today and didn't happen yesterday, and vice versa. We can explore the past with SQL queries in Athena and create the future with code in Lambda. Without a simple way to gain insight into activity, we let our code turn against us. These three systems work together to give flexibility where it's needed and safety where it isn't. They take a matrix of resources and rules and try to create software systems that work for people. Through technology, we create both our doom and our salvation. It enables our decision-making to become destiny, with consequences beyond our ability to predict. And the core of security technology is about protecting humanity. I hope we can all remember to recognize this responsibility, its power, and its frailty. Thank you. Question? It took me a little while. Once I had the video, it's I have some scripts I can share with you afterwards. Yes? When you're exploring the data with the data, how do you decide where to start? I mean, you're basically parsing logs and doing searches on logs. That seems like there could be a lot of logs to look at. Absolutely, yeah. So one of the things that I found is useful is like being able to describe scenarios that are interesting for a particular reason. Unauthorized access, I think, is a really good example of that. What that means is that you either are stopping a person or a piece of code from doing something they want to do legitimately, or something has gone really, really wrong and someone's trying to like do something bad. So to me, it's an indicator of compromise potentially, but it's also an indicator that things need to be changed. So that's a really interesting area to look at. I think also the idea of viewing changes can be really helpful, right? If you say, what are the new actions today? That can be a way to kind of zero in on, if you trust what happened yesterday wasn't malicious, does any of this new stuff look potentially interesting? And again, there's two sides of it. It's not just about trying to find indicators of compromise, but it's also about, trying to see if maybe people are using a service in a way you didn't expect. Yes? Yeah, it's basically like a domain-specific language for writing AWS policies in a way that it's YAML, so it's smaller than JSON, but also it's it takes away big, huge chunks of boilerplate. Yes. Yeah, well, we translate it to Terraform, which Terraform then translates it to AWS. Jim?
Alex, why were the T600 series terminators so easy to spot by the rebels?
Anything that's not in the original Terminator or T2 is not canon as far as I'm concerned. So, I don't. Oh, right, yeah. Wow, you're really grilling me on this, man. I just thought it'd be a cool, thing to add some videos with. Any other questions? Awesome. Thanks, everyone.